Hi guys, I'm going to be doing question 10a, November 2010, paper 1. Here's the question. The question actually gives you a graph of a function, f of x is equal to x cubed, and it also gives you 3 points, p, q, and r. P is a and f of a, q is 2 over 3, 0, and r is negative 2 and negative 8. And we know that a is greater than 0. And the first part of the question tells you to show that the gradient of PQ is a cubed over a minus 2 over 3. And we know from the question that f of a is equal to a cubed, and so we can translate p of a and f of a to p of a and a cubed. So using this and point q, which is 2 over 3 and 0, we can find the gradient of PQ. And m is equal to y2 minus y1 over x2 minus x1. You sub in the x values of p and q into x2 and x1, and you sub in the y values of p and q into y2 and y1, which gives us this expression, a cubed minus 0 over a minus 2 over 3, which translates into the equation that the question gives us. Part 2 tells you to find f prime of a, and given that f of x is equal to x cubed from the question, we know that f prime of x must be equal to 3x squared because of the power rule, and we can sub in x in a into x, which gives us f prime of a is equal to 3a squared. The final part of the question, part 3, tells us to show that a equals 1. And we can do this by looking at points q and r, which gives us the exact gradient of the tangent at x equals a. And using q and r, you can find the gradient, and you can see that the gradient is 3. So we know that pq, the gradient of pq, which is equal to the gradient of qr because it's a straight line connected, is also equal to 3. And you can use this to find that a is equal to 1 when gradient is equal to 3, because you can see that f prime of a is 3 at this point, and you solve for a, 3a squared equals 3, a squared equals 1, and a equals plus minus 1. But the graph shows that a is greater than 0, so a must be 1. Thanks guys.